Welcome once again. We are going to lecture 11 and we want to understand more about triglyceride chemistry. Triglycerides are also known as triacyl glycerols, and these are the main form of fat found in the body and in food. They are lipids, and so they are insoluble in water. As we earlier said that lipids are insoluble in water but soluble in organic solvents. They are stored in adipose tissue and used as energy reserves. Biosynthesis involves glycerol plus a fatty acid, and they are catalyzed by DGAT enzymes, and this is called diacyl glycerol acyl transferases. Industrial hydrogenation may produce trans fats. Triglycerides structurally are composed of one glycerol molecule, which is a 3-carbon alcohol with 3 hydroxyl groups, which formula is C3H8O3, and 3 fatty acids, which are long hydrocarbon chains with a carboxyl group at one end. These can occur as saturated or unsaturated fatty acids. Triglycerides undergo several reactions, and one of them we said is hydrogenation, and the other one is esterification. Here, each hydroxyl group of glycerol reacts with the carboxyl group of a fatty acid, forming an ester bond and releasing 3 molecules of water. The general formula here is a triglyceride is going to be equal to glycerol plus 3 fatty acids, which will release a triacyl glycerol plus 3 water molecules. The types of fatty acids in triglycerides, we note that we have the saturated fatty acids with no double bonds and solids at room temperature, for example, butter. We also have the monounsaturated fatty acids that have one double bond, for example, olive oil, and also the polyunsaturated fatty acids containing 2 or more double bonds, for example, sunflower oil. The importance and function of triglycerides, one is that they act as energy storage components. Triglycerides store about 9 kilocalories per gram of energy, more than carbohydrates or proteins. They provide insulation and protection in the body, and they are stored in adipose tissue. They also act as metabolic fuel. Fatty acids from triglycerides are oxidized in the mitochondria to produce energy to fuel our daily activities. Another reaction that occurs to triglycerides is hydrolysis and saponification. Triglycerides can be hydrolyzed to form glycerol and fatty acids, and with the presence of sodium hydroxide, saponification takes place, that is the formation of salt, and here we form salts of sodium of fatty acids. Enzyme catalyzed hydrolysis can also occur by enzyme lipase in the digestion process in the body. Rancidity in lipids. We say rancidity refers to spoilage resulting from the introduction of oxygen or introduction of hydrogen or introduction of other products. We have lipolytic rancidity due to lipase action, then oxidative rancidity initiated by oxygen radicals, which byproducts produced are aldehydes and peroxides, and then also antioxidants are the ones that are used to prevent the process of oxidation. The key antioxidants are BHA and BHT, which we shall later on look at in further detail. How do we measure rancidity? Rancidity can be measured by the peroxide number, and here we can use colorimetry or potentiometry. And the peroxide number measures the amount of peroxides, especially hydroperoxides formed during lipid oxidation, because these are the early indicators of oxidative rancidity. Then we can also use MDA quantification. MDA is malone dialdehyde. This is a secondary product of lipid peroxidation that is commonly used as a marker of oxidative damage to fats. We can also use UV spectrophotometry that can analyze for conjugated dienes and trienes. Comparison of the three methods in rancidity. The peroxide number is measured using peroxide concentration. The pros and cons. The pros is the good bit of it. It is a widely used method and it is an early indicator of oxidation. The bad side or the cons is that it does not detect advanced oxidation stages. Then the MDA quantification, the measuring type is the secondary oxidation product. The pros is that it's good for overall lipid degradation, and the cons is that it can overestimate MDA due to cross-reactivity. Then the third method, that is the UV spectrophotometry that analyzes for conjugated dienes. The measuring type is the conjugated dienes and trienes. The pros is that it's a quick and sensitive method to early oxidation, and the cons is that it only detects early oxidation products. Melting points and polymorphism. Triglycerides show multiple melting points due to different crystal forms. You can have the alpha and the beta forms. Packing is influenced by saturation and double bond geometry. Smoke points of oils. Smoke point is the temperature at which oil starts to smoke, and this is affected by refinement, free fatty acids, and also moisture, and it's an important aspect for frying. Higher quality oils are needed for stability. Texture terminology in fats. There are various terminologies we use when it comes to texture of fats. For the body, we have what we call the mouth feel, the way you feel when you're taking when you're eating these fat products. Then creamy is smooth and thick sensation, provides a smooth and thick sensation. Then gelatinous means springy, solid texture, and greasy is thick or oily feeling in the mouth. So these are the essential aspects of triglycerides and a few terminologies used in texture of fats. And thank you so much for listening. Let's meet again in the next class.